Okay, so having looked at those diamond problems, let's see how we actually use those. So you might have thought, well, you're just going off on a tangent here. This has nothing to do with factoring, but it actually has everything to do with factoring. So let's go back to this example that we've been working on. So we started with this polynomial, factored out the GCF, but now we're working on this leftover piece right here, 6x squared plus 17x plus 5. And we think that we might be able to break that down further, which we can. And we notice it has 3 terms. It's a trinomial. So we're gonna learn the technique for breaking down a trinomial into smaller bits. Okay, so you're going to use a variation of that box model that I showed you for multiplying. So this would be the box method for factoring. All right, so I'm excited to show you guys this because this is kind of fun. So let me start off. The way we start off is we're going to draw our box. So we draw a big box like we did before, rectangle model. So this rectangle represents our polynomial, our original polynomial. Now, for now, we're going to focus just on the leftover part, the 6x squared plus 17x plus 5. The 2x cubed that we factored out as a GCF, that kind of just carries along. So we're not going to worry about that part too much. Just focus on the 6x squared plus 17x plus 5. Just that term, just the term that's in the parentheses here. So let's just focus on that one. Now, it turns out we know that a trinomial will break down into 2 binomials, two-term expressions. So what we're going to do is we're going to divide our box in 2 sections each way. So we got 4 sections in our box. Okay, so watch carefully now. So I'm going to show you the setup. And this is the same for every trinomial, no matter what the coefficients are, what the powers of x are. Every trinomial, you set it up this way using the box model. So what you do is you take the first term. The first term is the highest degree term. We're going to assume it's in descending order. So the highest degree term is a 6x squared. You take the first term, the 6x squared, and you put it in this upper left-hand box. Okay, so first term always goes in the upper left. Then you take the constant term, which is the number on the end, the 5, positive 5. So that constant term goes in the lower right-hand corner. So 6x squared, first term in the upper left, constant term in the lower right. First term in the upper left, constant term, last term usually in the lower right. So that's how you set it up. Now, we have one more term. We have the middle term, 17x, and we have 2 empty boxes left. We have these 2 boxes here. So the trick is, how do we split up that 17x into 2 pieces that we can fill in these 2 boxes that will make the problem come out consistent? Okay, we can't just arbitrarily, we can't just kind of randomly say, oh, well, let's break it up into a 10x and a 7x. We can't just do that. We got to make sure we split it up in the right way so that everything works out consistent in the end. All right, so you can't just randomly take it apart in however you like. Okay, so the trick is, how do we figure out how to split up that middle term so that when we fill in the other 2 boxes, it's going to all make sense and come out consistent in the end. And the answer is, in order to do that, we're going to do a diamond problem here on the side. So here comes a diamond problem. Okay, so watch how I set up this diamond problem. So it's going to be like that last set of diamond problems I gave you, where we're going to know what the top number and the bottom number are. And we've got to figure out what the 2 side numbers are. So that's how this problem is going to work. Okay, so watch what I do. So to figure out what the top number is, what number goes here, what I do is I take the coefficient of the first highest degree term, which is 6, and I take the constant term, which is 5, and I multiply them together. I leave off the x's for now. Let's not worry about the x's. We just want to focus on the coefficients and numbers. So just take the coefficient 6 of the highest power term, highest degree term, and multiply by the constant term, third term. 6 times 5 is 30. And so that's what I'm going to put on the top of this diamond. Okay, so first times last, coefficients go on the top. Okay, then in the bottom, I'm going to put whatever the coefficient of the middle term is, which is 17. So 17 goes on the bottom. Okay, so that's how we set up this diamond problem. So it's first coefficient times last, first times last, 6 times 5 is 30, that goes on the top. And then middle, 17, goes on the bottom. It's always going to be like that. Okay, so now you might think these are kind of lots of rules to remember, but once you do a lot of practice with them, it's going to become second nature. So again, the setup for the box is first term goes in the upper left, constant term in the lower right. When you set up the diamond, first times last on the top, and then middle on the bottom. Okay, so now that we've got that set up, now let's do this diamond problem. So you guys are pretty good at this on the last one, so let's see if you can figure this out. So I got a diamond, 30 on the top, 17 on the bottom. So I'm looking for two numbers that multiply together. When you multiply them, gives you 30. When you add them, it gives you 17. Okay, so stop the video right now. If you can't think of it right away, stop the video until you find the solution. So what two numbers multiply to 30 and add to 17? So stop the video. Only start it when you figured it out. Okay, so should have figured out that 15 and 2. So 15 times 2 is 30. 15 plus 2 is 17. Okay, so if you figured that out, congratulations, because that's the hardest part of this process, is figuring out those numbers. So those numbers, the 15 and the 2, that tells us how to split up the middle term, the 17, correctly between these other two boxes so that everything is going to end up consistent in the end. Okay, so 15 and 2 tell us that we're going to split up the 17x as a 15x and a 2x. We'll put the x's back in the problem now. We ignored the x's for the purposes of doing this diamond problem just so we could focus on the numbers. But now that we got the numbers, 15 and 2, now we can go back and put in the x that goes along with that middle term. Okay, so 15 and 2 tells us that in order to split up 17x correctly, we split it up as a 15x and a 2x. That's what's going to go in these other two empty boxes. Now, it doesn't matter which box you put the 15x in and which box you put the 2x in. In the end, it's going to all work out the same. Okay, so you could put 15x in either of the two boxes. Okay, so I am going to put the 15x in this one. I'm going to put the 2x in this one. Okay, so that's how we split up the middle. Okay, so now we're ready. So now we got the box all set up. Now we can finally find our solution. Okay, so what we're going to do is we're going to start by going across the rows. So we're going to go from right to left this way across the top row. We're going to figure out what the greatest common factor is of these two boxes on the top. So the GCF of 6x squared and 15x. Figure out the GCF, and we're going to write that along the left-hand side here. Then we're going to do the same thing on the bottom row, 5 and 2x. So go from right to left, figure out what the GCF is, and we're going to write that along the side here on the left. Then we're going to do the same thing with the columns, going from bottom to top. So first column, 2x and 6x squared, I figure out what the GCF is. I write that on the top here. And then second column, 5 and 15x, figure out the GCF. I write that on the top here. Okay, so now we're going to go across the rows from right to left and write the GCF of each row on the left. Then up the columns from bottom to top, write the GCF along the top here. Okay, so first row, top row. We got 15x and 6x squared, so GCF. So first we do the coefficients, 6 and 15. GCF of 6 and 15 is going to be 3. Then we do the variables, x squared and x. Okay, you can think of it as what's the most number of x's they have in common, or what's the smallest power of x, which would be x to the first, or just x. So GCF is 3x. I'm going to write that along the left side. Then I look across the bottom row, 5 and 2x. So the GCF. Okay, well, 2 and 5, look at the numbers. 2 and 5, at first it may not seem like there is anything that divides into 2 and 5 evenly, both 2 and 5 evenly. And when it seems like that, often the GCF is just going to be 1. The GCF can be 1. So 1 is the biggest number that divides into both 2 and 5 evenly without a remainder. So the GCF there is just 1. What about the x's? Well, this first term, 2x, has x to the first, has an x in it. The 5 doesn't have any x's, however, so they don't have any x's in common. So the GCF of the second row is just 1, period, no x's. Now we do the same thing with the columns, going up the columns from bottom to top. So the first column, 2x and 6x squared. GCF, well, look at the numbers first, 6 and 2. GCF of 6 and 2 is 2. And then I look at the variables, x squared and x to the first. So the smallest power of x is x to the first. Okay, or that's the most number of x's they have in common. Then I go to the second column, bottom to top, 15x and 5. So first the numbers, 15 and 5, GCF is 5. X is, well, the top box has an x, the bottom doesn't. So they don't have any x's in common, so the GCF is just 5. Okay, now that I've got the GCFs, let's just double check just to make sure it all works out. Okay, so we just multiply the two. Let's just check by multiplying the edges together. 3x times 2x is 6x squared. Yep, that works for the first box. 3x times 5 is 15x. That works for the second box. 1 times 2x is 2x. That works for the bottom row, left side. And 1 times 5 is 5. That works for this box. Okay, so everything looks like it works out. So what do we get from this? Well, we get what our two factors are. We get 3x plus 1. So this is one of the factors. The left-hand side is one of the factors, 3x plus 1. Then we get 2x plus 5. The top edge is the other factor. So the two factors, when I break down this 6x squared plus 17x plus 5, turns out I can break it down further, and it breaks apart into a 3x plus 1 and a 2x plus 5. Okay, so let's put it all back together in that original problem. Okay, so what I found is that, just from doing this box, that 6x squared plus 17x plus 5 breaks down as a 2x plus 5 and a 3x plus 1. It doesn't matter what order you write the factors in, because multiplication is what's called commutative. Okay, that means you can change the order. So if you think about it like 2 times 3 and 3 times 2, those both have the answer of 6. It doesn't matter what order you multiply. So I could put them in either order. And so in the bigger problem, if I put it all back together in this big problem that we've been looking at, the original polynomial, 12x to the 5th plus 34x 4th plus 10x cubed is, now here's our GCF. We just carry it through, 2x cubed. And then now we were able to break down that trinomial into a 2x plus 5 and a 3x plus 1. Okay, so this would be the factorization. We would say the factorization of this guy right here. Okay, so this is the box model. Now, when you do the box model, so several important things. When you do the box model, it's always important that you go from left to right, right to left. Right to left when you're going across the rows, and that you write the GCF along the left-hand side. That you go from bottom to top when you're going up the columns, and you write the GCF on the top. That might seem like arbitrary, and it might at first not seem like it makes a difference, but I'm going to show you another example where we have some negatives involved, and when there's negative signs involved, then it's going to be important. So you always write the GCFs along the side, left side, and the top. Okay, so that's how you do the box method for factoring. As I said, let me show you one more example, and this one is going to have some negative signs. So we got to talk about how those negative signs work in there.